Hi, my name is Lantop. In this video, I'm going to put you to how to perform Euler's method using Matlab. Euler's method is a simple numerical technique for solving ordinary differential equations of the form. It is just a simple differential equation. Before we proceed in this class, I will implore you to subscribe to my YouTube channel to get notifications anytime I do videos like this. So what we want to do is to solve a simple differential equations. Euler's method is one of the numerical techniques used to solve ODE problems. So given that we have an ODE problems of this form, Euler's methods try to approximate it in form of this, using this formula. So this implies that, Euler's method approximates by estimating the next step, the next point, given the current point and a step size. So in Euler's method, we will need a step size called h. Then we'll need the current point to estimate the next point. So given the value of this current point and h, so we estimate this, then we multiply it by h to get the next point. So let's go through this particular example. Given this simple ODE problem, divide dx equals to x plus y, and we are always going to be given this initial problem. So for us to solve Euler's method, we will need the initial condition, which mostly could be the value of x of 0. So the y value of x of 0. So in our case, we have the y value of x of 0 to be equals to 1. Then we want to solve in this interval. We want to solve the problem in this particular interval of 0 to 2. Then we have our h to be, which is the step size, to be equals to 0.1. So now let's switch to Matlab. So firstly, I'm going to clear screen, then clear all variables. Possibly, you can also close all figures opened. Then you can define your equation like this. So you can define your equation like this. F of x comma y is equal to x plus y. So this is a function. This is a function handle that is going to take x points and y points. That is going to estimate x plus y. So we can also define some initial condition in given parameters that we are given. So in this case, we have x of 0. When x of 0 is 0, my y of 0 is equals to 1. So we also have h, the height, to be equal to 0.1. So the endpoint, I'm going to say that x end is 2 because our bond is from 0 to 2. Then we have this condition, y of 0 to be 1 and h to be 0.1. So you might need to estimate the number of points that we are going to compute. So you can estimate the number of points using this height, since you know that your step size is 0.1. So we can use that to estimate the number of points. So I'm going to say the number of points equals to n, which is x end minus x0. So divide by h. So this is going to give me the number of points to be estimated. Then I can then look through the number of points to start estimating each point, the value of y at each point, using this approximation formula of Euler's method. So to proceed further, I'm going to first populate some array for my all x points. So which is going to be from x of 0, height, and x end. So this is my x points. These are the points of x of 0, h and x end. So which also conform with this particular interval. So just that we factor in the step size, which is 0.1. Also, I'm going to initialize 0.0s for all my y points. So these are what's going to be populated as time goes on. So I know that all y points is also the length of x. So for each point, I'm going to estimate the value of y, the actual value of y, knowing fully that y1, the first point of y, is the y naught, as defined here. So which is this is the first value of point of y. Then now I can start estimating my methods using this Euler's approximation. Using Euler's approximation, then I can start estimating each point for I equals to 1 to n. N is the number of points I want to estimate. Then for each of these points, I will need to find the value of y. So using this formula, you can see n plus 1. So I can then say that I plus 1, because I will need to get the next point using the current point xi plus h times f of x of I. So I'm going to call, I'm basically calling this function f of this function s plus y function. So by taking the s points at that particular iteration and also the y point at that iteration. So with that, I got this value of y. So once you estimate all this, you get all your y's. That's just the last method. So once you are done with that, then we can then plot our figure, our plot, which is going to show all the computed points of y, given the x points. So I can say that plot x comma y, just a simple plot is enough for this. So x label, so just x, just a simple plot, y label y. So you might just feel like displaying it in the table in the tabular form. So I can use a display method to display my y and my x and y in tabular form. So I can just transpose the value of x and also the value of y. So okay, let me add some variable names. Names. So my variables are x and y. So I'm still just a presentation, just trying to present this in tabular form. Why the plot is going to also show all x point and y point. So this Euler's method in Matlab. So I'm going to run this code. I'm going to run this code. I'll wait for the execution. Okay, so you can see all x and y points in tabular form. When x is 0, which is the initial value of initial condition, y is 1. When x is 0.1, y is 1.1. So that is Euler's method. So it approximates it up to the 0.2, which was what we intend to get to, where we intend to get to. So I'm waiting for the plot to come up also. Waiting for the plot to turn up. This is the plot. This is the plot we get x points from 0 to 2 and y points from 0 to about 10 point something. So this is the solution for Euler's method. This is how you use Euler's method to solve an ordinary differential problem. So thank you so much for listening. Thank you for watching this tutorial. Like I said, please subscribe to my YouTube channel. Thank you. Bye.